Welcome to the tutorial over 1-5 Solving Inequalities. The new stuff you're going to learn about is self-builder notation, and let's talk a little bit about the addition property of inequality and the subtraction property of inequality. The way I see this is you can kind of think of the inequality as an equal sign, because if you had like 5 minus x less than or equal to 3, or 3. This would be the same thing as I can subtract 5 from both sides. I can still take this as negative x is less than negative 2. And then, of course, you divide and flip the sign and all that good stuff. But the point is if this was an equal sign, we would treat it the same way. Okay? So you can add things to both sides of the inequality sign, and you can subtract things from both sides of the inequality sign. If you take a look at the number lines real quick, all it's saying is if you started at B and you added C units, it would make you jump over to the right that many units. And if you look at the subtraction, if you started at B and you subtracted C units, it would mean you would move to the left however many units. Okay? So we're going to try our first example. It says solve 4y minus 3 is less than 5y plus 2, and then we're going to graph the solution set on a number line. So we're going to solve this just like there's an equal sign between them. We're going to get variables on one side, numbers on the other. So I'm going to rewrite the equation. And the first thing I want to do is to get the y's to the same side. Okay, so I'm going to subtract 4y from both sides. And you have to make sure that you combine the correct terms. Okay, here we're left with negative 3 is less than y plus 2. And the reason why it's just y, because we took 5 y's and we subtracted 4 y's, so that means we have 1 y left over. Alright, and for our last thing, we need to get y all by itself, so we're going to subtract 2. Okay, we're doing the opposite. We're going to subtract 2 from both sides. And that gives us negative 5 is less than y. Now, real quick, the only time you ever change the sign is when you divide by a negative number. Okay, so anytime you divide by a negative number, you flip the sign. But you do not do it when you're adding or subtracting. So you can also read this as y is greater than negative 5. Now, we actually have to graph this on a number line. So make sure you have this written down because I'm about to clear it. Alright, so we said y was greater than negative 5, and we need to graph this on a number line. And I'm going to have this as negative 5, negative 6, negative 7, and it keeps going on forever in that direction. And then we have negative 4, negative 3, negative 2, negative 1, and so on and so forth. Okay? We're going to have a circle at negative 5 because that's where we're starting. Now, to determine whether or not it's an open or closed circle, you have to look at your inequality sign. If there is not a line underneath it, okay, if there's not a line underneath it, then it's going to be an open circle. If there is a line underneath it, then it's going to be a closed circle. And I put the rules down there for you at the bottom. Okay, so in this case we have no line, so it's going to be an open circle. And we want values that are greater than negative 5. Okay, so that means we're going to shade to the right. Okay, because everything to the right is bigger than negative 5. Okay, so I actually have a prettier picture on the next slide. Okay, any real number greater than negative 5 is a solution of this inequality. And this is how you would show it on a number line. And this also means a circle means that the point is not included in the solution set because we did not have a line underneath our inequality. Alright, now I would like you to try an example. Alright, now let's talk about the multiplication properties of equality and division properties of equalities. Okay? Multiplication means that you can sit there and multiply something on both sides. Okay, so basically what we do when we have an equal sign. The only thing that you really need to pay attention to is when we get to the division property. Okay, when you divide by a negative number here, you end up having to flip the sign. So you see how we changed directions here? That's because we divided by a negative number. Okay, so that's very important. When you divide by a negative number, you flip the inequality. I put that at the bottom for you. When you divide by a negative number, you flip the inequality. So let's try another example. We're going to solve, and somehow part of my thing didn't show up. That needs to be greater than or equal to. 12 is greater than or equal to negative 0.3p, and we're going to graph the solution set on a number line. So the first thing we need to do is actually solve for p and get the variable by itself. So to get p by itself, I have to divide by negative 0.3. So negative 0.3, divide by negative 0.3. Now, when we actually put this in our calculator, 12 divided by negative 0.3 is negative 40. And then we have just p left right here. Now, remember, we divided by a negative number, so we have to flip our sign. Okay, so now it's going to be negative 40 is less than or equal to p. Now we need to graph this on a number line. So I'm just going to draw a number line right here. This is negative 40, negative 41. This is negative 39. And these do continue in opposite directions. Alright, so the first thing we want to know is whether or not it's going to be an open or closed circle. Well, I know that I have the line underneath here, so that means it's going to be a closed circle. And it's saying p is greater than or equal to negative 40. Okay, since it's getting bigger than negative 40, we want to shade to the right. So the numbers that are to the right are bigger than, and the numbers to the left are smaller than. Alright, the next thing I want to talk about is set builder notation, okay? Because we need to actually write this in set builder notation, okay? And the way you write it is with a curly bracket. You first define your variable, in this case is p. You write a vertical line, and then you'll write your variable, and then whatever way your inequality sign needs to go. Well, since the alligator is eating p, it needs to eat p over here as well, with our line underneath, and then negative 40, and then we will close our curly brackets. Okay, so this is called set builder notation. And this is the actual proper way to show your work and show your answer. Okay, so it's cleaned up a little bit here. The solution set is p, which is within, p is greater than or equal to negative 40, and the dot this time means that it is included, and we knew that because there was a line underneath our equality sign. Okay, so now you try an example. Example number 3, solve multi-step inequalities. It says solve negative x is greater than x minus 7 divided by 2, and then graph the solution set on a number line. Okay, in this case we need both x's to be on the same side. So the first thing I want to do is to get rid of this 2 on the bottom. And since that's division, the way you get rid of division is by using the inverse. So we're going to actually multiply both sides by 2. Okay? So we get negative 2x is greater than x minus 7. Because when you multiply by 2, these go away. Alright, so the next thing I want to do is actually take this x that's on the right and move it to the left. So since it's positive, I'm going to do the inverse. I'm going to subtract x from both sides. And what that gives me is, since I have negative 2x minus x, that's going to give me negative 3x is greater than negative 7, because these canceled out. In my last step, I'm going to divide both sides by negative 3, so that way I can get rid of the coefficient in front of x. And since I divided by a negative number, you have to make sure that you flip the sign. So what we're left with is x is less than, and see we have a negative here and a negative here. A negative divided by a negative is a positive. So x is less than 7/3. To write that in set builder notation, remember, we're going to write it exactly how we see it. We're going to have our curly brackets. We're going to define our variable, which in this case is x, vertical bar, and then x is less than 7/3. Okay, and that's the set builder notation. Go ahead and write this down because I'm about to clear the drawings. So now I'm going to put this on a number line. Okay, I'm going to start at 0, go to 1, 2, 3, -1, -2, -3. Now, the top of your head, if you don't know what 7/3 is in your head, you can actually think 7 divided by 3. Okay, well 3 goes into 7 2 times. Okay, so we have a 1. 3 can't go into 1, so we have our 0, bring it down, have our decimal. And so we say 3 goes into 10 3 times, so this is around 2.3-ish. Okay, so if we look here, we want to put our dot about 2.3. And then you have to think to yourself, okay, is it going to be an open or closed circle? Well, we look at the inequality, and we say that there's no line, so that means there's going to be an open circle. And the last thing to do is to shade, okay? We know that x is going to be less than 7/3, so we want all the values to the left, because that means they're less than 7/3. Okay, so now that we have our number line in our set builder notation, this is the answer. Okay, here's a prettier picture of what we just had. Okay, here's the set builder notation. 7/3 is right here on the number line, and we shaded to the left. All right, now you try an example. Our last example is number 4, consumer cost. Xavier has the most $15 to spend today. He buys a bag of pretzels and a bottle of juice for $2.59. If gasoline at the store costs $3.39 per gallon, how many gallons of gasoline to the nearest tenth of a gallon can Xavier buy for his car? I realize I just said his name wrong. It's Javier. So the first thing we want to do is write an inequality. Okay, so he has at most $15. Okay, at most $15. So we don't want to spend any more than $15. Okay, so the alligator is going to eat the 15. Okay, now we can actually spend $15. That means he would have no dollars left over, but it can actually be equal to it. Now we think, okay, he did for sure buy $2.59 for his bottle of juice and his bag of pretzels. And what we're trying to find out is how many gallons of gas can he buy with the rest of his money? Well, we have $2.59, and we're going to add the cost of the gas. And we don't know how many gallons he's going to buy, so I'm going to put an X next to the $3.39. Well, now we've actually written our inequality, and we should be able to solve it to figure out what G is. Okay, so the first thing I'm going to do is I'm going to subtract $2.59 from both sides. Okay, when I actually put that in my calculator, I get $3.39. X is less than or equal to $12.41. Okay, and our last step is going to be, we need X by itself. Okay, so I'm going to divide by 339 on both sides. Put that into my calculator, I get X is less than or equal to 3.6. And then you want to put this in words. This means that Javier can buy up to 3.6 gallons of gasoline for his car. Now I would like you to try a word problem. And that's the end of our tutorial. Thanks for watching. See you in the next video.